Welcome to today's lesson on arithmetic progressions. Today we're going to have a look at what an arithmetic progression is and how we actually work out terms within the arithmetic progression. So a sequence is a list of numbers that will follow a certain pattern. We've come across that in previous years. But if we have a series of numbers, then if you add up all the terms in that particular series together, it is called an arithmetic series. So just a few notation points to start us off with here. U with a suffix n is the term that we would use to describe the nth term of a sequence. So if you see U with a suffix 4, it means it's the fourth term of a sequence. And U to the suffix of n plus 1 is the term that comes after the nth term. So let's have a think about some series then, or some sequences. Well, at the top here, we can see I've written down 2. I've got 3, 8, 13, and 18. In this sequence, it adds on 5 each time. On the second sequence here, I've got 17, 15, 13, and 11. And on this sequence, it takes off 2 each time. So when the terms of a sequence progress by adding a fixed amount each time, or even adding a negative amount each time, it is called an arithmetic sequence or an arithmetic progression. The formula to work out the nth term of an arithmetic sequence is given by this here. So the nth term is a plus n minus 1 multiplied by d. Now, in this, a is the first term of your sequence. D is the common difference between each of the terms in the sequence, and n is the position of any term. So let's have a look at this in practice then. We're going to find the nth and 20th terms of this arithmetic progression. So it starts with 2, 5, 8, 11. It could look like this, though, being asked in a slightly different way. For the arithmetic sequence 2, 5, 8, 11, we are being asked to find U20. That means it's the 20th term that we're being asked to find of this sequence, and a formula for the nth term of the sequence. So how do we do that? Well, in this case here, we know that to find the nth term, then it's a plus n minus 1d. Well, what do we know? Well, from here, we know that a is equal to 2. And if we have a look at the gaps between each term, they are adding 3 on each time. So therefore, d is equal to 3. Now, if I substitute that back in to my expression here, then my nth term will be 2 plus n minus 1 times 3. So we've substituted in a and d. We can expand this bracket by multiplying each term in the bracket by 3. So to put it simpler, it's 2 plus 3n minus 3. And if we simplify the right-hand side here, then we can simplify 2 and take away 3, giving us minus 1. So the nth term will be 3n minus 1. Now, how does that help us find the 20th term? Well, in this case, we want to find the 20th term. Then it will just simply be 3 times 20 plus 1 using our information. So 20th term will be 60 minus 1. So the 20th term of this sequence will be 59. So second example then. The second term of an arithmetic sequence is 21, and the 9th term is given as minus 7. We are being asked to find the 23rd term. Well, if I want to find the 23rd term, then I need a plus n minus 1d. So in this case, that would be 23 minus 1 times the common difference. 23 take away 1 is 22. So in order for me to find out the 23rd term, I need to find out what a is, and I need to find out what d is so that I can multiply it by 22. So what do we know then? Well, the second term, that's a plus 1d. So the second term, U2, is A plus D is equal to 21. That means the first term plus the first difference will give me 21. And for the ninth term, well, that will be A plus 8D, n minus 1 here is 9 minus 1, so that's 8, and that's equal to minus 7. Now, if we ignore this bit here now we've set up our two bits of information, hopefully you can see that I have got two equations that I can solve simultaneously. Now, if you have a look carefully, we can remove A from here by eliminating A. So we can subtract these equations. And I'm going to subtract these. So I'm going to subtract going up my column here. So A take away A in this first column is 0. I'm going to start with 8D take away D, that's 7D. And here I'm going to start with minus 7 take away 21, which is minus 28. So as you can see here now, we can solve that. And if we divide through by 7, then D will equal minus 4. So the common difference in here is minus 4. We found D, but we also need to find what A is. So we've got D. Well, what can I do here to find A? I can substitute D equals minus 4 back into one of the two equations. I'm going to choose equation number 1, which is A plus D equals 21. So I've got A plus minus 4 for D equals 21. So what can I do to both sides? Well, I can add 4. So A will in fact be equal to 25. So I've now found what A is, and I've now found what D is. I can now work out the 23rd term of this sequence. So to work out the 23rd term of this sequence, then it's simply A, which is 25, plus 22D, which is 22 times minus 4. That is, put more simply, the same as 25 take away 88. And if you take 88 away from 25, it will get you minus 63. So the 23rd term in that arithmetic sequence is minus 63. I would take a moment now to make sure you understand that, maybe make some notes on what the examples are shown, and then I would like you to have a look at the main task, which I've attached to the assignment called exercise 2.1. Have a go at all those questions there. When you've done that, what I would like you to do then is have a look at this checking question and see if you can work through that as well. If you've got any questions at all about any of that work there, please just send me a message on Teams. Good luck.